This is a flipped video for graphing a parabola from a quadratic equation written in standard form. So here is a reminder that the standard form for a parabola is written y is equal to ax squared plus bx plus c. As a review from our last unit, when our leading coefficient is negative, our parabola opens down, and when it's positive, it opens up. We get a parabola that becomes more and more narrow the larger our a gets from our parent function. Y is equal to 1x squared. So when our a becomes larger than 1, our parabola becomes narrower, skinnier, and when it is less than 1, it becomes wider. Some new vocabulary from this lesson is that we now have an equation for calculating our axis of symmetry, and that is x is equal to negative b divided by 2a. Our vertex has x coordinate, x is equal to negative b over 2a, and so then we can use that x value to plug into our original equation to find our y value of our vertex. Note that when we have our x-intercept, our x value is always 0, since any x touching the x-axis has to be 0, and that our y value is determined by our c value. So let's look at how we can use these to help us graph parabolas written in standard form. So first thing I want you to do is I want you to note our a, b, and c. Since this is very new to us, this would be a great way to help us keep them straight. So as a reminder, our axis of symmetry has the equation x is equal to negative b divided by 2a. And for this equation, we have negative 2 divided by 2 times a negative 1. And this is negative 2 divided by negative 2, or just positive 1. So our vertex then has x coordinate 1, and then we can plug our x into our original equation to find our y value. So y is equal to negative times 1 squared plus 2 times 1 plus 3. And this gives us the value 1 squared times a negative, or just negative 1, plus 2 times 1 is 1, plus 3. Negative 1 plus 2 is just 1, plus 3 gives us the value positive 4. So the y value of our vertex is 4, and that gives us our coordinate 1, 4. The y-intercept always has x value of 0, and our c value for this equation is 3, so we have y-intercept 0, 3. So we now have 2 points, 1, 4, and 0, 3 to graph on our table. So I'm going to pick 2 more points, negative 2 and negative 1. When I plug negative 2 into my original equation, I get y is equal to negative 2 times 2 plus 2 times a negative 2 plus 3. This gives me negative 2 squared, or 4 times a negative, which is negative 4, and then 2 times a negative 2 is a negative 4 plus 3. So negative 4 plus negative 4 plus 3 is negative 5. And so I have the point here, negative 2, negative 5. Plugging in the negative 1, I have y is equal to a negative 1 squared plus 2 times a negative 1 plus 3. And this is negative 1 squared times negative is negative 1 plus 2 times the negative 1 which is negative 1 plus 3, gives me negative 1 plus 2, which is 1 plus a negative 2, which is negative 3 plus 3, which leaves me with the value 0. So I have the point negative 1, 0. So I now have all the information I need to plot the points on my graph. I start with my axis of symmetry located x equals 1, and I continue with my points with vertex 1, 4, which is located here, and then I have 0, 3 for my y-intercept. I can reflect this across my x-axis, or my axis of symmetry, which gives me point 1 to the right, located here. I have my next point at negative 1, 0, which is also one of my solutions. It is 2 to the left of my axis, so I can plot another point 2 to the right. And then I have the point negative 2, negative 5, which is located right here. Since this is 2 to the left of my axis of symmetry, I can now go 2 to the right, and that gives me this point here. And my parabola has a shape like this. Okay, so let's look at one more example. Here I have the equation negative 3x squared plus 6x. First thing I want to do is note my a, my b, and my c. Since there is no number here noted, we can add 0 to this equation, and note that our c value then must be 0. So our equation for our axis of symmetry again is x is equal to negative b over 2a, and for this equation I have negative 6 divided by 2 times a negative 3. Negative 6 divided by negative 6 again is positive 1. So we have the x-coordinate of our vertex of 1. Plugging that into our original equation, we get y is equal to negative 3 times 1 squared plus 6 times 1. When I solve for this, I get negative 3 plus 6, or just positive 3. So my vertex has the coordinate 1, 3. Again, our y-intercept has x value 0. And since our c in this case was invisible, we can add 0 to our equation, and it gives us a c value of 0. So our x-intercept this time is located at 0, 0. So I now have 2 points that I can plot onto my graph. I have 1, 3, and I have 0, 0. I'm going to pick another point at negative 1. And when I do this, I plug it back into my original equation to find my y, and I get y is equal to negative 3 times a negative 1 squared plus 6 times a negative 1. When I do this, I get 1 times a negative 3 is negative 3 plus 6 times a negative 1, which is negative 6. Negative 3 plus a negative 6 is negative 9. So I have a third point that I chose at negative 1, negative 9. Now I have all the information I need again to start plotting my points. So I have axis of symmetry located at 1, and then I have 1, 3 as my vertex. I have 0, 0, or my origin for my y-intercept. I reflect that across my graph, and I get this point here at 2, 0. And then I have my third point located at negative 1, negative 9, which is right here. And that reflects 2 to my right of my axis, and that gives me that there. Notice this graph is fairly narrow since we have a leading term of negative 3, And just like in the last problem, we have a negative number, so it is opening down. So in review, quadratics written in standard form have the equation y is equal to ax squared plus bx plus c. Our new equation for our axis of symmetry is x is equal to negative b divided by 2a. Our vertex, or our xy coordinate, has the equation, or has the x value negative b over 2a. Should be a negative b over 2a, and y is the value that then we get by plugging this value back into our original equation. Our y-intercept always has x value 0 and has c then for the y value. Don't forget to write your summary. Thank you.